Dear students, let us begin the second part of the lesson, in which you will learn about the constructing the test statistic and obtaining the test critical values with the defined level of significance and type of test. To construct the test statistic and obtain the critical values for hypothesis testing with a defined level of significance and type of test, follow these steps. Step 1. Define the level of significance alpha. The level of significance denoted by alpha represents the maximum probability of making a type 1 error, that is rejecting the null hypothesis when it is true. It is predetermined by the researcher and commonly set at 0.05, that is 5% level of significance, or 0.01, that is 1% level of significance. Step 2. Choose the type of test. Determine the type of test based on the research question and hypothesis. The two common types of tests for comparing means are the one sample t-test, two sample t-test, and paired t-test. Step 3. Calculate the test statistic. Calculate the test statistic based on the chosen type of test and the sample data. The formula for the test statistic varies depending on the test. Here are the formulas for the three common t-test. One sample t-test, test statistic t, it is equal to sample mean minus population mean divided by sample standard deviation by square root of sample size. Two sample t-test, equal variances assumed. Test statistics t, it is equal to mean difference by pooled standard deviation into square root of 1 by n1 plus 1 by n2. Paired t-test, test statistics t is equal to mean difference by standard deviation of the differences by square root of sample size. Step 4. Determine the critical values. Determine the critical values based on the level of significance and the degrees of freedom associated with the test. The degrees of freedom depend on the sample sizes and the assumptions of equal variances. You can refer the t tables or use statistical software to find the critical values corresponding to the desired level of significance. One-tailed or two-tailed test. One-tailed test. In a one-tailed test, the critical region is located entirely on one side of the distribution. This type of the test is used when you have a specific directional hypothesis. The critical value is determined based on the chosen level of significance alpha and the tail of the distribution where the critical region is located. Two-tailed test. In a two-tailed test, the critical region is divided between both sides of the distribution. This type of test is used when you have a non-directional hypothesis, where you want to determine if there is a significant difference without specifying the direction. The critical values are divided equally between the upper and lower tails of the distribution based on the chosen level of significance alpha and the desired confidence level. Obtaining the critical values. T distribution. If you are using the t distribution, critical values can be obtained from the t table or calculated using software. The critical values depend on the degrees of freedom, which are determined by the sample sizes and any applicable adjustment based on the test being conducted. For example, paired t-test. Standard normal distribution. If you are using the standard normal distribution, that is Z distribution, critical values can be obtained from the standard normal distribution table or calculated using the software. The critical values are determined based on the chosen level of significance alpha and the desired confidence level. Rejection rule. To determine whether to reject the null hypothesis or fail to reject it, compare the calculated test statistic with the critical values. If the calculated test statistics falls within the critical region, beyond the critical regions, we reject the null hypothesis. Rejection rule. If the calculated test statistic falls outside the critical region, within the non-critical region, we fail to reject the null hypothesis. From the figure, we observed that in one-tailed test, there is a rejection region in either left side or right side, and in two-tailed test, the rejection region is in the both sides. Step 5. Compare the test statistics with critical values. Compare the calculated test statistic with the critical values obtained in step 4. If the test statistics falls within the critical region or beyond the critical region, the null hypothesis is rejected. If the test statistic falls within the non-critical region within the critical values, the null hypothesis is not rejected. Dear students, let us summarize what we have learned in the second part of this lesson. We learned about constructing the test statistic and obtaining the test critical values with the defined level of significance and types of test. Dear students, I hope you understood all the concepts. We will continue in the next video. Thank you.